24 blocks going up and 13 going across.
Okay. So you did the area model that you read about, right? So you said, okay, we had 24 one way, right? Which would be like 2 rods and 4 ones, right? And 13 going the other way, right?
Yeah.
So this side is 13 and this is 24. And then what did you do from there?
Count it in.
So you filled it in, right?
Yeah.
Because there you've got like a rectangle. So a 10 and a 10, if you want to fill in right here, what goes there? A flat, good. And here?
A flat.
Another flat, right? Because we're saying, okay, this is a 10 by 10, so it's a flat. This is 10 by 10, it's another flat. What goes right here?
Rods.
Rods for each one of those, right?
Uh-huh.
Okay. And then how about down here?
Rods for going 2 up.
Like that, and over here as well?
Uh-huh.
Alright, good. And then how about over here?
Just the little blocks.
Right, because it's just a 1 by 1 spot, right? So, we should have something that looks like that. Okay, and so then looking at this model, where did you get your answer?
We put the 2 flats together to get 100.
Okay, so we counted up those.
I mean,
and said
200.
200.
And then we counted the number of rods, and there were 10 of them.
Okay, which is
100.
100.
And then we had 12 little blocks.
And then you counted up the 12 of those and got 200 plus 100 plus 12, which is 312. Good. So there are a couple different ways that you could model the multiplication in this instance. This one is probably a little bit better in that you don't need quite as many rods and blocks, right? Because if we're doing 13 piles of 24, we're going to start running out of blocks. But both ways you get the same answer. You get that 312. So let's look at this and look at it a little differently. So we're talking about an area, right? When we multiply, we're finding the area of something that is, in this case, 24 by 13. So if we just look at it as a rectangle, well, couldn't we divide that up? Couldn't we say this is maybe 10 and 3? So this side is 13. And this side, and we've got a 10, well, a 20. Let's just, a 20 and a 4, right? So could we divide this up? Could we say, okay, well, I know 10 times 20, I'm sorry, I keep drawing that line in the wrong place. 10 times 20 is what? 200. So we have a rectangle in here of area 200, but we still have some more area, right? So do you know 3 times 20? This rectangle?
60.
60. Good. How about 10 times 4? 40. Good. And what about 3 times 4 for this rectangle? 12. Okay, so we found the areas of the rectangles, smaller, maybe easier rectangles inside this 13 times 24. Now, how would we get the area of the entire rectangle? Add them up, right. So 200 plus 40 plus 60 plus 12, which is 312. What we're looking at here, right? The 200, so this would be a 60 and the 40 together, the 112, right? So we go ahead and add those up. Okay, and this is that concrete to abstract model that we've talked about before that would be really good to use with your students so that at the end they understand the standard algorithm, what we're used to doing when we multiply two numbers, okay? So you could start off with the area using the blocks so they can physically see by counting up that this area, or this answer, 24 times 13 is 312. Then you could go ahead and look at it a little more abstractly, maybe drawing it, right? In the rectangle like this to get the same answer. Okay, so those are the two ways that we're looking at it as an area. Now, who remembers the distributive property? Anybody think they can recite it? Yeah? Or explain it?
It's just
this, like, if you have a number or if you're doing multiplication, like, can I just, like, write it on the
Yeah, go for it.
This distributive property basically just says like you have A and then B equals C, that equals A times B plus A times C.
Good. Okay, I'm going to go ahead and write that up here as well so we can reference back to it. That's perfect. So the distributive property says we can distribute this A, whatever number it may be, so that we get AB plus AC, right? And we're all used to using that. So let's look at this problem in this way. We said here that we got the same answer when we did, 10 plus 3 and 20 plus 4, right? So we could look at it like this. We could say, all right, 24 times 13 is 20 plus 4 times 10 plus 3. Everyone okay with that? So that works. All right, so we could say, all right, now we want to solve this problem. So here we only have an A and a B and a C. So for now, we're just going to call all of this A. And we'll call 10B and 3C. So far, so good. So we've got this part, A times B plus C. What would this side look like if we were to distribute the A? What would that look like? We're going to distribute everything that's inside these
So it'd
parentheses.
be 24 times 10.
24 times 10.
Okay.
Times 3.
And let's go ahead and keep it as 20 plus 4 for now. Times 10 plus, and then we're going to do it again, right? 20 plus 4 times 3. Is that okay? So we just distributed that 20 plus 4 to the 10 and the 3. Now, it looks like we have the same thing again, right? We've got an A and a BC, an A and a BC. So let's finish this so that it's all distributed. What does this first one look like? 10 times 20. Okay. Then what? Plus 10 times 4. Everybody see how this works? So this is our A, this is our B, C. So we distribute the 10 and the 10. And then we're going to do it here as well. So we've got, now 3 is our A, 20 is our B, 4 is our C. So what have we got over here? 3 times 20 plus what? 3 times 4. Now these are broken down into simpler ones that we can do, right? So what do we get? 10 times 20 is? 200. 10 times 4 is? 40. 3 times 20 is? 60. And 3 times 4?
12.
It's 12. And so our final answer would be 312, which is the same answer we got here and here and there. Good. So we can use this distributive property to break down this problem, which is kind of ugly, 24 times 13, into stuff we know how to do. 10 times 20, 10 times 4, a lot easier multiplication. Everyone okay up to here? That makes sense? Okay, awesome. So, this is starting to look a little bit more abstract, right? When you were in elementary school, middle school, junior high, whenever they taught this, and you were confronted with something like this, where you had two pluses, right, and you're multiplying together, what did your teacher tell you to do?
20 plus 4.
Uh-huh.
Do that, and then 10 plus 3 do that, and then times them again.
Okay. And what if they had something that was like, x plus 3 and x plus 7, things you couldn't add together inside? What were their instructions? Do you remember what we had to do?
Foil.
Foil, right? They always said, okay, foil it. I don't even remember what foil stands for, but that was what they told us to do.
First outside, inside, last.
Uh-huh. So, can we use this in all cases? What if I had like 10 plus 3
That makes sense.
times 20 plus 4 plus 7?
That's funny.
Well, now I've got 3 over here, and this falls apart, right? So instead of thinking about it as FOIL, which only works if we've got these 2 terms times 2 terms, we talk about U, like the sheep, which stands for everything with everything. Okay, so you just take one and you put it with everything inside the others. Then you take the other one and you do everything inside the others. And that will hold no matter how many terms you've got in each of your parentheses. So this is a better way to show your students than FOIL, which only work in some occasions. And of course, first, you'd want to go over the distributive property so that they can see why you have to do this. Does that make sense? Because a lot of times our teachers didn't go over this, they just said, okay, just FOIL it, and we didn't know why we were doing it. But if you look at the distributive property, suddenly these steps make sense. Because if we had FOILed this, isn't this what we would have gotten? 20 times 10, 4 times 3, 4 times 10, 20 times 3. The same 4 terms, right? So, we talk about the distributive property, and then instead of FOIL, talk about U, everything with everything. So each one of these terms needs to be multiplied. Okay? Does that make sense? And a little bit clearer than FOIL, especially for your students. Alright. So, now we're going to go ahead and talk about the instructional algorithm. We've gone from the concrete over here with the blocks and then drawing the box and doing the area to a little more abstract with the distributive property, right? But we still see how it comes from this. So now let's talk a little bit about the instructional algorithm. Okay, so we've got 24 times 13. So in the instructional algorithm, we go ahead and start on the left. So, but first we need to look at this, is this one really a 1? What is it? It's a 10, right? So we say this is a 10 and this is a, the 2 is a 2 10s, right? So 20. So we're actually multiplying 10 times 20. And what do we get? 200. Good. Now we're going to take the same 10 and multiply it by 4. Is that really a 4? This one is really a 4. Not 4 tens. Good. So we're going to, the 10, this is a, we talked about this is a 10 because it's 1 in the tens place. So 10 times 4, which is 40. Good. Alright. Then we'll go ahead and do this 3. So we'll take the 3 times the 20, right? 2 tens, which is 60. And then 3 times the 4, which is 12. These are called partial products. Basically, we've taken the different parts and multiplied them together. The same sort of thing we were doing over here, but a little bit more compact. Is that all right? Then we just add all those up. And what do we get? 312. If we were to go ahead and do this, like with the scratch method we learned, right? Well, that's 2. Then we get to 10, 1. And then you count the scratches, 1, 2, 3. 312. So are we good? Okay. So this is the instructional algorithm that kind of bridges the gap between this, right? And the standard algorithm, which is the next one, which is the one that we're all used to. So let's go ahead and do the standard algorithm, and you can all walk me through it. What you learned in middle school, how would you do this problem?
4 times 3.
Okay, so we take 3 times the 4 and we get 12. So what do I do? Put the 2 down here. What do I do with the 1, the 10? I exchange it. Where do I put it? Where am I going to write down that I got a 10? Up here?
Yeah.
Good. So there's the 10, there's the 2, right? Then what do? So we did 3 times 4. What else?
3 times 2.
3 times 2, which is?
6
6 plus 1 is 7.
Okay.
And then a 0
right there? Placeholder, right? Because now we're talking about tens. So then I take this 1 and I do what? Just 4. So I put the 4 right here. That look good? And
1 times 2 is 2.
okay, and I add the 1, right?
No.
Oh, okay, why not? Because I used it last time. Okay, good. So we're not going to add the 1 this time. We're going to say 3. No, I'm sorry, 2. Multiplying, not adding. All right. And our answer is 2, 312. That all right? Okay. So if your students don't see this progress from concrete to abstract, what kind of problems could they have with the standard algorithm? What kind of mistakes could you make? Yeah.
Putting the 4 under the 2 and forgetting the place value there.
Good. Yeah, I could forget to put this 10, this place value right here. I didn't have to worry about it because I was saying this is a 10 times a 20. So I'm not worried about place value. I know that's 200. Good. So they could forget that they need to worry about the placeholder, 0. Also, with the carrying, right, the exchanging. I put the 1 up there and I wanted to add it both times. Is that a common problem? What could you tell your students if they have that problem? Erase it. Okay. And what if you're trying to check their work afterwards and don't know what they did because they erased it? Probably a better thing to tell your students is to go ahead and scratch it out after they've used it. So then, because sometimes you'll come across a problem like, let's see, like if you have some 74 times 23, something like that, where both times, I'm gonna make that bigger. Okay, so both times I multiply the 6, right? I'm gonna have to exchange, bring something over here. So when I do 3 times 6, I'll get 18, right? And when later I do the 2 times 6, I'm gonna get a 12, and I'm also gonna bring that up there, right? So could they get confused? Could they try and add 11? Or say, okay, is it the 1 or the 2? Sometimes they'll be different with other problems, and they'll have a 2 and a 3, and they won't know which one to add. So the best way to go is to go ahead and tell them to scratch it out in the standard algorithm once they've used it, so that they don't try and add it again or try and add the wrong number. Is that okay? All right. So, looking at this, we got the 312 every time, right? So, let's talk about how these, we've got our concrete to our abstract. How do they relate? Can we find the parts in each one? So over here, we had 2 flats, that was a 200, right? So where's the 200 in this model? Right here, right? This big rectangle is the 200. Where's the 200 over here? Right, when we distribute it's right there. How about in the instructional algorithm? It's that first one, right? Was the 200. What about over here? Where's the 200? That 240? Yeah, can you see that? How did we get these from these 4 numbers? We've got a 72 and a 240. I don't see just a 200 there.
And the 12 is the 72.
The 16 and 12. Good. And the 200 and the 40. So these partial products, actually when we add the 2 of them together, we're going to get the 2 from the standard algorithm. Is that okay? So yeah, really what we've done here is we've just kind of cut down on a couple of steps and added these 2 together and these 2 together. That make sense? All right. So awesome. So we found the 200. What about the 60? There was a 60 over here, wasn't there? Here we had like 6 bars. It was in that 100. This was a 60 here and a 40 there, right? So we've got the 60 here. How about over here? Right here, right? We've got our rectangle that has an area of 60. And we have a 60 in this equation a 60 here, and we just talked about how the 60 is actually inside that 72, right? It's the 60 and the 12 together. So can you see how each of these parts, each of these pieces of finding this total area or this total product is in each one of these steps, which is something valuable that you can show your students that, okay, as they go from concrete to abstract, they'll see, wait, I'm doing the same thing, just a little bit different process, right? We're developing this algorithm, this process that we're all used to. We're developing it from something they can see and feel to, where they can go ahead and do the numbers with any numbers that they have, okay? All right, so let's look at this. Could we do this in a different base? Here we used base 10 blocks and we did everything the way we're used to in base 10. Could we do this in a different base? Probably, yeah. We could, so we could do it in, say, base 8. Let's work with, let's do 75 times 46 in base 8. So you don't actually have to do it, but what would this model look like if we were trying to do a concrete model in base 8? Instead of having base 10 rods, they'd be worth 8, right? Okay, so actually let's go ahead and do that. I'll do it over here. We'll just draw it up on the board. You guys can describe it to me. So we have 75 times 46, is that right? In base 8? Okay, so what would that concrete model look like with the blocks? What would that look like with these two numbers in base 8? Let's go ahead and take the 75. What is that telling us? We have 7 what? 7 groups of 8. So rods are 8, right? So we're going to say one rod is 8. So we've got how many of them? 7. And then 5 what? 5, 8 to the 0, right? So just 5 ones, so we would just use the little unit ones. Okay, so there's our 75. These would be like base 8 blocks. And then the 46, what would that look like? We've got 4 what and 6 what?
4 rods.
Good. And 6 of the little cubes. Okay. This one's kind of big. So, what would we do then, now that we've got them lined up? This is our 75 times 46.
All the rods and then put a block.
So we put a flat every time we got a rod by a rod, right? This would be an 8 squared, right? 64. So we'd have flats in all of these positions anytime we've got a rod times a rod. Oh goodness, that's a lot of flats. Alright, so we would do this, etc. Not going to draw them all out. And then anytime we had a unit times a rod, what would we get? We'd put rods all here, right? All across. And then when we got over here, we had just our units by units. We would put just units, right? So we'd end up with a 5 by 6 of units right here. Is that okay? So you would fill that all in, and then what would be the answer? Just how would we find the answer once we had this all filled in? What did we do over there? Counted, right? So we'd say, okay, how many 8 squareds do I have? That's the flats, right? So you'd count those up. And in the end, you might have to do some exchanging. You might say, okay, I have so many 8 squareds here that that's actually a few 8 cubes and a few 8 squareds. Is that all right? You count up the rods. So every time you got to 8, you would exchange, right? So you would go ahead and just count them up. Do any exchanging necessary, and you would get the answer. Just like we did over there with the concrete model. We could do the same thing. you know, going from concrete to abstract, but let's go ahead and just skip to the instructional algorithm in a different base. So let's talk about 75 base 8 times 46. And we're going to go ahead and do the instructional algorithm in a different base. Okay? So, like we did over here, which side do we start on, left or right? Left. Good. So, we need to, working with these, here we had sort of placeholders, right? We worked on the left, we said this is a 10 and this is a 10, so we need 2 zeros. We're going to do the same thing here. We're going to call them placeholders. 2 zeros. And then we'll do the 7 times 4. What's 7 times 4? Okay, and what would that be in base 8? How many 8s are in 28? 3, with how much left over? 4. So it would be a 34 in base 8. So far so good? Alright, so now we did the 4 times 7, let's do the 4 times the 5. We need one placeholder, right?
Or
4 times 5 is
you're doing 70 times 40.
20, which is how much in base 8? How many 8s are in 20?
No, that's
2
like it's
with
not,
how much
if it was
left over?
7 times 40, then it would
Good,
be.
so we're
this
gonna
is
have a 2
70
there
times 40,
and a
there's
4.
2 zeros at the end.
Because we've got
So
2
it's
8s
places.
and 4 left over. Alright, last one we're going to go ahead and do the 6 times the 7. We've got one of them that's to the left, so we're going to have one placeholder there as well. 6 times 7 is 42. And in base 8, that is good. 50, right? 50 how much? Because that's 5 8s and 2 left over. Is that okay? 6 times 7 is 42. 5 8s with 2 left over. And then we do the last one, which is 5 times 6. Do we need a placeholder 0? No, because we're both doing the unit.
40 times.
So let's do 6 times 5, which is 30.
So that's 20.
And in base 8, that's
30, 20.
3
Right.
with how much left over? 6. Good. Alright,
Okay, what she did.
then like we did over here, we go ahead and add them up. And we need to remember that we're
So
in
if we
base
did 40
8.
times
So,
5, that'd be
0 plus 0 plus
200.
6. 6 is okay,
40
right?
times 5 is...
We're in base 8, 6 is 5.
Yeah, it'd be 200.
4 plus 2 is 6, plus 3
Yeah,
is...
but that's in base 10. So you
9.
need to, like, because 4 times 5
Okay.
is 20, right?
So we've got too much.
So how many times is 8?
We have at least 1 8 there, right?
Twice.
So,
There's 4
and how much
left
left over? 1.
Oh, okay.
Good. Now we have 1 plus 4, 5 plus 2, 7 plus 5, 12, right? 12 is how much in base 8? We've got how many 8s in there? 1. We got an 8, and how much left over? 4. Good. And then 1 plus 3 is 4. So it should be 4416 in base 8. How could we check our answer to see if that's right? Yeah,
Okay, wait.
we could change under base 10, right?
So 6 times
So
7 is 42.
this would be what?
And then you do 42.
5 times
by
8 to the
8,
0,
see
which
how
is just
many
5
eights
times
are
1,
in there.
right?
Right. It's gonna be
Plus 7
525.
times what?
Well, 5.25.
7
So
times
why
8,
don't we
right?
put the
8 to
5
the
on
1.
the 520?
And then this would be 6 times 8 to the 0, which is 1, plus
Decimals
4
that come with that, that's all from
times
base
8,
10.
right?
So like you only take
So
how
what do
many
we get?
times it goes in, and then you take the remainder.
75 in base 10 is?
Or 0.25 is not the remainder.
What?
Because 8 times
61?
5 is 40, right?
Yep. And this one
So you
is?
get to 42, there's 2 left over.
38.
And that's why it's only a 5 next to it.
I'm sorry, thank you. 38.
So when you're doing
So
like
go ahead and do
bases, you don't
61
ignore
times
the
38 in base 10 and see what you get.
decimals. Okay, that makes sense.
On the 3400, how can you put 2 zeros behind it?
Because we were doing the, it would be the 10s if we were base 10, right? But the 8s, we were in the second place value on both of them. So we needed like a placeholder for this one and a placeholder for this one.
Okay.
So like over here, we were talking about 10 times 20. See how there's 2 zeros behind that? So we could have said, okay, I need a placeholder for the 20, a placeholder for the 10, and then just a 1 times 2.
Okay.
Which is basically what we were doing over here. We just talked about holding the place with zeros, and then just doing the multiplication straight up. Is that okay?
Yeah.
All right. Anybody get what 61 times 38 is in base 10?
2,318.
Okay. And then let's change this to base 10 and see if it's 2,318. So that would be 6, right, times 8 to the 0, which is 1, plus 1 times 8, right, plus 4 times, what?
8 squared.
8 squared, good, plus the next 4 times what?
8 cubed.
8 cubed. Somebody want to throw that in the calculator and tell us what you get?
It's the same. 2,318.
Good. So we just checked our answer, and this is all right because we got the same thing in base 10. So 4416 in base 8 is that. Everybody okay with how we did this process in a different base to get the answer? Any questions on how to do that? Okay, awesome. All right. So, just to sum up really fast, and we'll take questions. We're going from the concrete to abstract, making sure that we kind of maintain those different parts, right? We looked and we could find the 200 in every step. We could find the 60 in every step. So that your students can see the similarities, that finding the area, you know, physically with blocks or with drawing a picture is the same as doing these math processes. So, this process is really how we get to the instruction or the standard algorithm that they're going to be using for the rest of their lives. Is that all right? Does anybody have any questions about any of these processes? Want to do a practice one in this one or in a different base? Yeah.
Can you just do the one on the different base in the standard?
In a standard algorithm? Okay. Yeah, I think we could do that. So if we were talking about, let's just go ahead and take the same problem, make sure we get the right answer. Times the 46. So if we were to do standard algorithm, we'd start at the right, correct? So we would do 6 times 5, which is 30. In base 8, that's 8. Okay, good. So 30 is, what do we say, 36, right? So we put the 6 there, and we've got 3/8. Is that okay? Then we go ahead and do the 6 times 7 in base 8, which is, 6 times 7 is 42. Base 8, that's, I have to remember if you need to add the 3 before.
8 times 5. So it can go into.
So it's 42,
No. Yeah.
45, right?
No.
When you add the 3.
Oh yeah. 45.
And then in base 8, that would be
Yeah. 55.
55. Yeah. Okay. I think that's okay. Good. Yeah, because we've combined this one and this one, right? To get 556. 526. Good. All right. Then to the next one, we go to the 4. We need that placeholder, right? We do 4 times 5, which is 20, and in base 8, that is 24. Good. So we go ahead and bring the 4 down and put the 2 up here. We crossed out a 3 so we don't get confused. 4 times 7, 28 plus 2 is 30, which in base 8 is 36. So if we add those together, do we get this in base 8? We get 6, 9, which is 1, and we carry the 8, right? 11, 12, which is 1 8 with 4 left over, right? 1 plus 3, which is 4. Should be 3, 6. So we got the same thing. Just combining those. Is that alright? Everybody understand that process? Awesome. Do you have any questions? Okay. Okay. Then if you will go ahead and put away your base 10 blocks, and if anybody wants to see me about taking those arithmetic quizzes, you can come up and we can try to work out so that you can make them up. Remember that next week is the last week you can do it, yeah?
Well, the distributor